This is about the Hohmann transfer from one orbit to another. I did this with PHET, the solar system, and these numbers that you see here for Mars, Earth, and the spacecraft, it took me quite a while to adjust them to make it just right. And one of the things that we can see here is that Earth being closer, here's the radius of Earth, Earth being closer has the higher speed. You know, there's more gravitation, so it needs a higher speed to stay on its orbit. Mars being further away and has a lower speed. By the way, they're in reverse order so that I can actually match the pink planet with Mars and the blue planet with Earth. Oh well. And then the spacecraft here, that one actually has a higher speed than Earth because it needs to take off from Earth. So let's go over to FED and let's look at it. So here I have the 3. This here would be Earth. There is the spacecraft taking off from Earth, and then there is Mars. And I'm going to start this one here, and we can see that there's the spacecraft taking off from Earth and then getting to Mars orbit, respectively, because it keeps on going. I cannot stop it. It actually goes back to Earth. So you can actually see the nice transfer here. Of course, I'm going to reset here. In a moment, you can see that the spacecraft is not going to meet any one of them at any given point. I wasn't that accurate, and it only needs to meet at one point, but I'm going to reset it. So here I adjusted them in such a way that the spacecraft would be launched when Earth and Mars are in a certain position, so that it can actually match up with it. And there it would go. And hopefully get into orbit. The trick here is also that it starts with a relatively high velocity here from Earth, and as it goes out, gravitation is trying to pull it back in, so it's going to slow it down. So when it's further out, it's actually slower. In fact, it's actually slower than Mars when it gets out there, which is why it would actually fall back into its lower orbit, matching Earth. So what would have to be done then as it approaches Mars, it would actually have to get a boost in order to match Mars velocity and then get an orbit around it. Okay, that's my animation. I have another one here from Desmos. So here we again have Earth's orbit, and I should actually reset this to 0. There we go. So here's Earth's orbit. Mars is the spacecraft is about to take off. There is Mars. It looks kind of like the same position that I had. And so the person who did this also did a pretty good job here, did quite a bit of work putting in. I try to make this slow here. So the spacecraft is taking off. It's actually faster than the Earth. I know it doesn't look like it, but it's being slowed down by gravitation. Now it's actually quite a bit slower, and now it would actually have to get a boost in order to match Mars's. And then in this Desmos animation, they actually turned it off as if it had landed on Mars in this case. So that's the Hohmann transfer to get from one almost circular orbit to another almost circular orbit with using this more elliptical orbit here, taking off with a larger speed, arriving with a smaller speed over here.